Logical connectives and truth tables. Propositional logic basics. What are logical connectives? Logical connectives are symbols used to combine or modify statements. They are used in propositional logic and help form complex logical expressions. They are a core part of mathematical reasoning. Now let's look at the key connectives. And, represented by the symbol and, means both statements must be true. Or, represented by or, means at least one is true. Not, represented by not, gives the opposite value. If then, represented by implies a result. Let's understand each one. First, and, also called conjunction. Symbol and. Both statements must be true. It is used to combine two conditions. Key rule. It is true only when both parts are true, and false in every other case. Real-life example. I study and I pass. Both conditions must hold. Next, or, also called disjunction. Symbol, or. At least one statement is true. It is used when multiple choices exist. Key rule. It is false only when both statements are false, and true in every other case. Real-life example. I study or I watch TV. Either option or both is acceptable. Now, not, also called negation. Symbol, not. It reverses the truth value of a statement. True becomes false, and false becomes true. It is used to negate or deny a proposition. Example. It is raining becomes not it is raining. Key idea. Not always flips the truth value, no exceptions. Now if then, also called implication. Symbol, implies. It is read as if P then Q. It represents a conditional relationship. It is used in logical reasoning and arguments. Example. If I study then I pass. Key idea. P implies Q is only false when P is true and Q is false. Now, what is a truth table? A truth table is a complete outcome map. It shows every possible result of a logical expression. It is an analysis tool that helps us understand how connectives behave. Each variable is binary, either true or false. Key idea. A truth table lists all possible combinations of inputs systematically. Now, the structure of a truth table. We take two variables, P and Q. Each can be true or false. So the total combinations are 4. It is used to evaluate logical expressions. Key idea. It is a systematic way to check every possible case. Now, truth table for and. Both P and Q must be true. Symbol, and. It is true only when P is true and Q is true. When P is true and Q is true, the result is true. When P is true and Q is false, the result is false. When P is false and Q is true, the result is false. When P is false and Q is false, the result is false. Key idea. Only one true case, when both inputs are true. Now, truth table for or. At least one must be true. Symbol, or. It is false only when both are false. When P is true and Q is true, the result is true. When P is true and Q is false, the result is true. When P is false and Q is true, the result is true. When P is false and Q is false, the result is false. Key idea. Only one false case, when both inputs are false. Now, truth table for not. Not flips the truth value. Symbol, not. It is a single variable operation. When P is true, not P is false. When P is false, not P is true. Key idea. Simple inversion. True becomes false. Finally, logic in the real world. Programming uses if/else statements with and or and not. Decision systems like AI and expert systems rely on logic. Digital circuits use these connectives in processors. Access control systems use conditions like if login correct, then access granted. Key idea. Logic is the foundation of all modern technology.